Hey guys, Steve, your electronic mechanic here, and we are going to pick up right where we left off. Now, there's a couple modifications to the actual code that I want to make. Some simple things such as defining the transfer settings. And I'm going to say this is the counter for the LIN Bus signal. And what I wanted to do was I actually wanted to move this line print from up here, because what it's doing is it's printing a new line every single time it runs through, pulling each thing. And I want to put it down here. And what you'll see is that once I put it here, it's going to make things actually a little bit easier for us to see when we hold the button. So let's give this a try and let's see how this looks. Okay, so we actually see the lines running through more quickly, and let's go ahead and let's try pressing volume up. That's nice and clean. Look at that signal coming through. We press volume down. So I'm actually going to simplify this a little bit. I'm going to remove this, let's say, message entirely. Okay, and then the other thing I'm going to do is I want to change these all to just simply print. That's going to make it a little bit cleaner. All right, that's uploading. Now it's done. Now let's see how this looks when we press a button. Very nice. Very nice. Much better. That's what we were wanting. Not that it makes any difference, but it kind of just looks visually a little bit better. Now, just a reminder, this does not get impacted by us pressing the cruise control buttons, right? Because those are not actually routed through the Melexis chip. Those are through a separate resistance ladder that we're not going to touch right now. So now what we want to do is we figured out a way to get ourselves to have a digital reaction. Now we want to find a way to have a physical reaction to our actual changes and things that we make. Now, what I have here on my desk is a whole bunch of common cathode LEDs, RGB LEDs. So let me see if I can adjust you guys so you can see this a little bit better. But we have a bunch of common cathode RGB LEDs, and we're going to actually go about setting these up in such a way that we can actually control these based on the button we press. So let's do that now. So I'm going to put 1, 2, 3 here. Okay, let me do another one here. We're going to do one more over here. And we have one final one here, which we will put down. Now, the reason for us, now each one of these, remember, is an RGB LED, so I get 3 lights, and that should give me an opportunity to have 3 times 4. I have 4 LEDs, I have 3 lights apiece, so that should give me the ability to externally control 12 different signals, 12 different buttons, and on the controller we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 buttons. So that should be enough. Now I have myself some resistors here, so I'm going to go ahead and get my resistors all set up. All right, that's 6. That's half of them done. You know what? Let me see. Perhaps this will help a little bit. Let's try to do. Maybe some zooming in. Maybe that will make it a little bit easier for us to see. And that was not what I wanted to do. Okay, that looks a lot better. So now you guys can see that. And you can't see the steering wheel, but you'll just have to trust me on what I'm pressing and what is actually happening will match up. So let's get our last couple resistors in here. I think I have 7 in at this point. 8. Now again, this is a little bit messy here, but it's just for testing purposes. This is number 9. Number 10. And actually, I don't believe I have another resistor of the same size, so I'm just going to take a random resistor because anything is probably better than nothing, and I'm just going to plug this in, and we should still at least get some color, even if it's a little bit dim. Okay, so now we've got 11 resistors across our RGB LEDs set up for us. Now what do we need to do? We need to set up the ESP32 in such a way that it's going to output a signal depending on the button that we press. So what do we need to do? The first thing we need to do is we need to define what button presses what pin. So let's do that now. /set the pins for the audio controls. Define, and we're gonna say let's just roll right through them. Pin vol up, and we're gonna define that as 22. Why 22? It's just because that's what I want. And it's pins that are available that I'm familiar with. So we have volume up, volume down. We're going to have favorite up, favorite down. We're going to have the OK button. We will have talk. We will have hang up. And then we have our directional buttons, right? We have up, down, left, right. And we're going to define these pins as such. 1. I want this one to be 19. I want this one to be 18. How do I know these pins? Well, it's because I've written them down, and these I know are pins that I can use to control outputs on. That's what you want to do. You want to make sure you're targeting pins that you can control output digitally when it comes to the ESP32. Okay, so now we've actually set up our pins as such. These are going to be our controls for our chip, right? So we're going to use the ESP32, and we're going to set these pins based on when a pin was pressed and when something happened. or when we press a, not when a pin was pressed, when we press a button, it's going to set the pin based on what we determine that we want it to do. So where do we go about doing this? Well, we go about doing it right in here. So we want not just to set the favorite, to print favorite up, but we're going to actually want to change what takes place, right? Or change the pin. So we're going to say for favorite up, we're going to print favorite up, but we're also going to set digital write, and the pin we want is pin, right? Pin fave up. And we want to set that to high. Okay, what that means is we're setting the voltage out of the ESP32 to high when we press the up button. So let's close that out and let's send this over. Now, while that's being sent over, we'll go up and we'll say, what is the fave up button? It is pin 19. So now what I want to do is I want to set pin 19 to one of these resistors. And so I have, as I said before, I have all of these tracer wires without the hole and with the hole here that I'm going to use. And it looks like we got a pretty bad error. So let's take a look. Digital write. Pin fave up. High. Okay, what is missing here? Oh, yes. Yes, I did mean that. Okay, so while that's loading, I'm going to take a singular one, just because it's going to be easier for me to test this once. And I'm going to plug this into pin 9, so probably shouldn't be handling this while it's on, but I'm going to do it anyway. Pin 19, pin 19, pin 19 is right here. It's 3 up from my RX pin. So I plugged it into pin 19, and I'm going to come over here and I'm going to plug it into, let's say, this one. Then what I do need to do, though, is I need to ground these. And so I'm going to have to find a simple wire like this one. And I'm going to connect that ground to the ground over here. Okay, so let's go back to our output serial monitor. And if we press volume down, we get volume down, right? We get everything we're looking for. Now, let's see what happens when we press our favorite up. We get favorite up, but we get nothing. Okay. I would have anticipated that working. Let's try a different one just for a second. Favorite up. No. You know what? Just to test this out, let's try just feeding some voltage directly into these. Okay. So we know those work. Or, what happens if I put it here? Oh. Okay. So, I wonder if these are actually common cathode and not common anode, or they're common anode instead of common cathode. And maybe this is wired backwards, perhaps. Either way, we should still be seeing something coming out of this one, and we're not seeing anything. Which leads me to believe that for some reason my digital pin set didn't work correctly. Oh well, this isn't even plugged in correctly, so... Oh yeah, so something... So this must be bad. These must be all common cathode. Well, common cathode is what I want. But why did my serial stop running? I fried it. Ah, God, man. I fried the ESP32. I told you guys, don't mess around with the power. Don't mess around with the power. Don't mess around with the power while it's plugged in. Okay, we'll return in a bit. Okay, guys, sorry about that delay there. We've got ourselves a new ESP32. As I warned you, don't make the same mistake I did again. I have gone back and I've double checked all of my LEDs. Some of them were common. These over here are common anode, and that's not what we want. We want common cathode. So that was a big issue we had. So I'm going to go ahead and go back here, and I'm going to try to re-upload our code to a brand new ESP32. And let's see what happens. Okay, we have port not working. What does that mean? Unless this is an ESP32, that doesn't work. All right, ladies and gentlemen, I am down to my last ESP32, so this could very quickly become the end of this video, or we can make progress. So let's see what happens. So before I connect anything, I'm just going to plug in my ESP32, and we're going to see if my computer can detect it. Not connected. Well, I really hope I didn't fry my USB ports again. All right, so now what we can do is we can finish up putting in these flags. Okay, so we got favorite up, favorite down, volume up, volume down, up, down, left, right, I believe this is okay. This is talk. And this is hang up. So now we should have everything set up. And the most important thing is that when we clear it, the light should turn off as soon as we let go. Because remember, as soon as it completes the loop, it's going to turn it off. This should put us in such a situation where when we hold the up button, it's going to act as if we're pressing it many times very quickly, which is pretty much exactly what we want from the system's perspective. So let's wait for this to finish loading. Now what should happen, right, is, oh, okay, this says clear outputs, and I put, okay, so we have no light on here. Let's see what happens when we put favorite up. We got our green, and now from my perspective, it's constant on. You guys may see it flashing, but for the most part, it's a constant on. So there's no issue with a delay there. And honestly, what we could do if we needed to is we will eventually comment out these serial prints, which should speed up the speed with which the code operates. But otherwise, now we're lighting that LED. What should theoretically be happening is all of the rest of these should be lighting up. So what we're going to do is we're going to get a long amount of our little wires here, and we're going to set them all up. Now, obviously what I'm going to do first is I'm going to disconnect my ESP32, and I'm going to disconnect my power source because I don't want to make any mistakes or have any issues where I've put the wrong ones in the wrong place. So let's just go through our pins and make sure we have them all set up. So we have 19 here. All right, we have, and honestly, I'm not really going to keep track. All I want to do is I want to make sure that each one has its own LED that it can light. We have 21, and we have 22. Okay, and those next two pins are RX0 and TX0, so I don't need to worry about those. Then we're going to go to the other side. So as of right now, we have 1, 2, 3, we have 4 pins set up. We have 7 more to go. So we have, oh, you know what? We have pin 4. Pin 4 and pin 5. All right, pin 5. pin 4, pin 15, and is 22. Oh yeah, we do have a pin 22. I don't know why I plugged into pin 23. 23 is not one of them. Pin 22. Okay, in addition to this, we are going to grab, so how many is that? That is 1, 2, 3, 4, 5, 6, 7, 7 pins. So we have 8 more to go. So most likely we have pin 12, 13, and 14 on the other side. And pin 27. How many do we have here? 22. 21. 19. 18. So that's 4. Then we have 4, 5, and 15. Okay. I don't know. My math seems to be... Oh, no. Yeah, that's good. So then we have 4 on the other side, right? We have... And you know what? I'm actually going to leave that white one off, and I'm just going to plug these in. All right, now we need 4 more. I'm going to see if I can do it with, these are really short. I don't want to use these. Do I have a long? I got this one, which is super long. All right, so I'm going to go with the last 4. And we're going to go into (27, 12, 14). 12, okay, 12, 13, 14, which are here. And 27, which is right next to it. And then we're going to take these and we're just going to plug them in over here, just like the rest. So we have 1, 2, 3, 4. Okay, so now we've got a whole bunch of craziness over here with all of our pins. Let's give this a shot and let's see how it goes. So I'm going to plug my power in. And before I do anything, I am going to spot check all of my connections here. Because right off the bat, I can see that my... well, that's not good. Okay, it would appear that my digital readout has come, I'll use the term unsoldered, but it actually came out entirely. So what I am going to do is I am going to quickly solder that in. And you know what? I'm going to take the power out. Sometimes we just have to make do. Okay, so that should be attached now. So let's pull our power back in. Okay, we got 11.9, which is accurate. That's what we're expecting from our system, 12.3. So now I'm going to plug in my ESP32 and hope I don't fry anything. Okay, so everything is off. Now what we should see is each one of these RGB LEDs change based on what button I press. So we got number 1 blue for favorite up. Favorite down is number 1 green. Volume down is number 2 green. Volume up, number 2 red. Let's see, down. Down is number 4 blue. Left is number 3 blue. Right is number 3 green, 4 green. OK is number 4 red, 3 red. 3 green, 1 red, 2 blue. So now, this is huge progress. This is what we've been wanting to do all along. We are at a point where each one of these buttons that I'm pressing on the steering wheel has a separate analog output. Okay? So now what we need to do is, based on being able to control these, we need to find a way to take each one of these button outputs and simulate. We want to simulate a resistance ladder. Okay? And how we do that is this fancy little chip I'm going to drop right over here that we will talk about in our next episode. So, a little bit of a hiccup here and there, but now, guys, we are at a point where we have our ESP32 interpreting our steering wheel. It's now, we're able to send the signal out through our ribbon cable into our pins and control separate LEDs, which in the case of this, I'm going to give you guys a heads up. What we'll end up most likely doing is something along the lines of controlling like a transistor or a MOSFET, where we will have our resistance ladder all set up coming out of the BCM, the body control module, zipping right back around to the ground, and instead of it going into the steering wheel, it's going to go into a converter box for us that will have the simple resistance ladder, and then based on the digital signal we get from the LIN Bus, that will determine where we flip the resistance ladder and send that signal back to the BCM. That seems all complicated. It sort of is, but we'll get there, one step at a time. So, for those of you who joined and made it to the end, thank you for watching. I appreciate it. I hope you learned something. I'll catch you in the next one. See ya.